Fabian for having me to talk today. So today I'm going to talk to you about spatial spillovers from urban renewal, evidence from the Mumbai Mills Redevelopment. And this is joint work with Mike Gechter, who's at Penn State. This is much more preliminary than other work that's happened in the series, which I think is going to be good for us because we're going to benefit a lot from all of your input. Okay, so the motivation for this project is the simple fact that a huge amount of developing country cities are going to be built in the coming decades. So to take one example, in India, there are going to be around 250 people moving into its cities by 2030. And this equates to roughly the equivalent of the floor space, the same size as Chicago, being built every year. Okay, and so while these cities are currently characterized by a fair amount of low quality slums, a huge amount of this new construction is going to consist of tall, formal sector buildings that are built at high heights using modern construction technologies. And just to get a kind of gauge of the scale of this, the total value of construction in the pipeline in India in 2019 exceeds 30% of the country's GDP. So these are really huge investments that are going to be taking place of this kind of higher quality buildings. And I think it's important to focus that these are going to be due both to kind of underlying market forces, whereby developers are going to want to profit from increasing land values and redevelop old lands, including slums. But there are also going to be a host of government policies targeted towards this kind of urban renewal. And this can range from kind of direct policies like slum clearance that actively look to replace slums with new formal sector buildings, but they can also be indirect ones such as the changing of relaxation of land use regulations and building height restrictions that can change the incentives of developers to build formal buildings in these cities. But as we try to think about the impacts that these policies are going to have, the evidence that we have so far of externalities within cities across space means that these policies can have potentially transformative effects beyond the directly targeted areas into neighborhoods nearby. And so trying to gauge kind of the size and nature of these spatial spillovers is going to be crucial to learn about the total impact of these policies, as well as the potential unintended consequences that they may have on places nearby. Okay, and when we see a discussion of these sorts of policies within the news media or policy circles, it typically tends to center around this trade-off or discussion of winners and losers from this class of policies. So if I take this news article that I found last night on the Wall Street Journal in Mumbai, we can think about the impacts of these the development of these 3 or 4 construction high buildings in the background. Clearly, on the one hand, these may create a lot of value. They may increase the land values close by. It may increase the amount of floor space for people to live in. It may promote the agglomeration of formal sector employment. But at the same time, if these construction leads to appreciation of land values close by and different people moving in, then it may cause slums to convert into formal housing. And the incumbent residents to be displaced and lose the locational advantages that those housing units had. By chance, these 3 buildings in the back were actually the ones constructed by due to the policy that we're going to study in today's paper. So this is just kind of one anecdotal evidence of the kind of story that I'm going to show you more formally in the data, that when developers build new formal sector buildings, these can kind of have pretty transformational impacts on the constitution of neighborhoods nearby. Okay, so with this motivation, we're going to have 2 key research questions in this project. The first are, what are the spatial spillovers from formal housing developments? Okay, so on the one hand, the kind of first order effect, we might just think about house prices. So how does increasing the build quality in one location capitalize into land values nearby, and how does that decay through space? But we also want to push past that and think about the broader impacts on city structure. So do these kind of investments promote a process of gentrification that lead to new, richer individuals moving in who are willing to pay in these high quality formal buildings, leading to the conversion of slums and displacement of incumbent residents? And what are the employment impacts? So do we see informal employment being displaced by formal employment? Does that lead to an increase in informal employment concentration within developing country cities? The second question that we're going to want to ask is, what are the welfare consequences of these policies? And we think of there being an equity efficiency trade-off inherent to these policies, as kind of hinted at by these news articles. So on the one hand, these policies may promote a more efficient city structure with denser agglomeration of formal employment, making cities more productive and allowing people to live in more compact, dense cities rather than urban sprawl that characterizes cities of the developing world at the moment. But at the same hand, there can be this cost on equity if we have these displacement and slum conversion effects. Okay, so when we think about answering these two questions, we think about there being three inherent challenges to getting a precise answer. Okay, so first, developer decisions are clearly endogenous, and so their choices of where to build and the underlying locational fundamentals are just correlated. So it's very hard from the cross-section to say anything about whether, if you see correlations in house prices near formal sector buildings or slums, whether that's actually due to the formal sector buildings or whether it's due to just correlated fundamentals through space. So we're going to address this challenge in this paper by using a rather remarkable and unique policy change that led up to 15% of land in central Mumbai to be redeveloped during the 2000s. And so for these formal skyscrapers to go up. The second challenge we're going to have is that there's a lack of data to measure outcomes at fine spatial scale within developing country cities. So even if we had our perfect kind of policy, it would be very hard to measure the effects just because rich administrative granular data doesn't tend to exist very often in these settings. So we're going to address this in three ways. First, we're going to bring a set of newly digitized administrative data to the table on land prices, population, and the universe of informal and formal establishments. Second, we're going to provide the first application of a deep neural network, a frontier technique from machine vision to measure slums from high resolution satellite imagery. And we'll use that to measure the change in slums over time in response to our policy change. And third, we'll use classification techniques from machine learning to measure the change in demographic composition of neighborhoods from the change in the types in the composition of names from people who are registered to vote across different neighborhoods. And this is going to work in our context in India, because in India names are informative about caste, and caste is in turn informative about socioeconomic status or education. And then finally, even if we have all this evidence and we can measure it in the reduced form, it's going to be hard to both disentangle the direct effects of spillovers from the indirect effects due to all of this reallocation, right? So if we see house prices change near these new buildings, how much is due to the house prices versus how much is due to the changing structure of employment, slums, the types of people who are living there, and so on. And then second, it's also going to be hard for us to parse these multiple impacts, all of these moving pieces, and ultimately pass them through to think about the net effect on welfare and whether and how cities should be implementing these policies and potentially with complementary policies to address some of these unintended consequences. And we're going to address this challenge by bringing to the table a quantitative dynamic spatial model, where the key features are going to be to introduce informal and formal housing sectors, non-homothetic preferences for neighborhood quality and housing quality, as well as relocation frictions across space. And we're going to estimate the parameters of this model by an indirect inference procedure to match the reduced form regression coefficients that we're going to use steps 1 and 2 to generate. Okay, in the interest of time in this short presentation, I'm going to skip over the literature discussion, but I'm happy to come back to that. And so before we get into the institutional background, let me stop to see if there are any questions.
I think we're good, Nick. That was very clear. Just as a reminder, you can put questions into the Q&A box, and if they're of clarifying nature, I will ask them pretty much immediately. So please preface them by clarifying. But I think for now we're good to go, Nick. Yeah.
Perfect. So I'll stop after each section, but feel free. I'm sure there's going to be lots of questions when we talk about the institutional background. Okay, so Mumbai's textile mills were a booming industry back in the late 1800s and early 1900s. And they were located across 60 large buildings that covered 15% of land in the central city. But over time, the city pivoted from manufacturing towards services. Land prices rose in central areas, and it was kind of no longer viable for textile production to take place there. It moved out to peri-urban areas. And so this industry kind of declined. And by the early 1980s, most of these mills had completely shut down due to following some strikes that occurred in the beginning of the 1980s. So what I want you to have in mind is something like meatpacking in New York, which was once productive for a particular type of land use, manufacturing. But over time, that relative productivity changed, and in turn, land use changes. And now today, meatpacking is a kind of hotbed of service and retail activity, very high-end residential real estate. But in Mumbai, this wasn't possible. So prior to 1991, owners of these mills were explicitly forbidden from selling or redeveloping any part of these mills. During the 1990s, they were allowed to redevelop, but only if they gave 2/3 of the land of these mills to the city government. So clearly, given the size of these mills, these were huge assets, and the owners were reticent to do that, presumably anticipating some probability of this being lifted in the future. This all changed in 2001 when the DCR 58 law change was implemented. And this law change now effectively lifted these restrictions and said that mill owners were free to redevelop these mills. This policy was challenged in the court, through the courts, and it went all the way up to the Supreme Court, where it was eventually upheld in 2006. So upheld, it was the original decision was confirmed. Okay, so and if we look just anecdotally at a couple of these mills, we can see that this policy change led to really transformative impacts on these sites. So here's an example of a clearly non-functional mill back during the 1990s or 1980s. I'm not sure exactly when this picture was taken, but clearly you can see there's nothing taking place here. It's completely overgrown and out of use, but it's a very big site with very big buildings. This is a photo that my co-author Mike, who I think is listening in, took during his trip one Christmas to Mumbai. I think this was 2 years ago, and I'm not sure if this is exactly the same mill. I don't think it is, but you can see this neighborhood has been completely transformed, and it now counts Lamborghini and Porsche among some of the entrants into these locations. Okay, we can then kind of zoom out and look, still anecdotally, but just see from space what was happening around these mill sites. So here, what I'm showing you is an area surrounding 3 mills in the year 2000. And these mills are outlined here in blue. And so there's 2 things I want you to take away from the image. First is just, the mills are pretty clearly demarcated from space. They have these very long tiled roofs because of their, very land intensive needs. But then the rest of them are kind of overgrown. So there's lots of green, kind of consistent with those pictures that I showed you. If you zoom in and you compare it with the streets nearby, you don't see any people, you don't see any cars. They're just completely out of use. The second thing that you can see is these kind of slums just by the mill, which are pretty, just kind of pop out to the naked eye by their very small kind of clustered nature. There's no kind of gap or green space between any of the buildings. The actual footprints of the buildings themselves are small, and they have this kind of dull, kind of textured pattern to them, which immediately is kind of recognizable to the eye. Okay, so this is in 2000. And now let's fast forward to 2016. Okay, so there's 2 things to see in this image. The first is that if we look on each of these mill sites, every single one, each of these 3 is undergoing kind of large scale redevelopment. So we see these very large skyscrapers going up in each case. And in fact, this was the one that I realized this morning was the same one from that Wall Street Journal article I showed you before, these 3 buildings in the background. So this is, we can think of this as kind of some visual first stage that this policy is kind of having some bite and is changing activity that's happening on the mill sites. But the second thing to see is kind of what's going on these slums close by. So here, we had this large slum in the year 2000, just south of this mill. And then by 2016, a large portion of it has been redeveloped into formal buildings, and this area is also in the process of being cleared. So just from looking at images like this, it kind of we kind of notice like this policy is having very, very real impacts on the structure of Mumbai, but B, these kind of spatial spillovers, but kind of jumped out to us and kind of made us think that these are going to potentially be really first order impacts of these kind of policies that incentivize construction of formal modern real estate within the center of developing country cities.
Nick, we have what I think is a clarifying question, which is who owns the land that the slums are located in? State or private companies, owners, etc.?
Yeah, so most of the land in Mumbai is owned by the government on where slums are located, or initially they were. And so, these are areas that are just greenfield, and then when people are moving into the city, they just, they construct slums there. And that's not to say that now nobody has ownership rights. That's kind of changed a little bit over time. That's kind of a longer discussion. So there is some kind of murky property ownership within slums. We also have some data on like whether residents are owning or renting. There's a fairly high rent share. I think it's around 55% or something, but yeah. So I hope that answers that question. Okay, perfect.
Sorry, Nick, Gabriel here. One question, can you tell us how should we think of the mills before? Were they sealed off, and so should we think just completely inaccessible land, or were they actually maybe dangerous, or I don't know?
Yeah,
disamenity.
So to answer the first question, if I could zoom in, I would show you there's basically nothing going on the mill sites. But to the second question, that's not to say that they're not a disamenity. Let me show you one result. So we're going to look at changes in house price and outcomes near these mills. It could well be right that this is not due to the formal buildings. It's just due to the fact that we're removing this disamenity that was there. I'll show you one regression that seems to suggest that that's not what's happening. In short, we can look at somewhere, control for how far away you are from the nearest mill, and then use variation in the density of overall mills that you have close by. And so that's going to do something to show you that it's not at least all about just being close to a mill. It really is about the amount of new development that's going on that's affecting land values. Okay, great. So let me talk about data.
Nick, before we move into that section, we have kind of quite a few questions, I think, relating to what you just showed. Do you want to take some of those now, or?
Let's take maybe one now, just so we have enough time to get through everything.
Okay, I think there's a good question by Nina Harari, or actually two questions which have received a lot of upvotes. So Nina, if you want to ask that question yourself.
Sure. Yes, so my first question was about the process by which developers acquire land and clear slums. If you could tell us a bit more about how that happens, the land acquisition, is it contentious? Does the government play a role? And then my other question is where the mills are located relative to the CBD, just so that we understand, to what extent this is really highly sought after land, or where is this located in the city?
So this is perfect. I have two backup slides to hit both these questions. So here is the mill locations, which is kind of a little bit just quicker to see. So this is Mumbai district. Mumbai itself in our analysis is going to consist of Mumbai city, which I'll call, which is this area, like up to here, and then Mumbai suburban, which is everywhere north. And so, yeah, you can see that most of this land is in, fairly central areas. It's highly sought after. To answer your second question, how does slum redevelopment work in Mumbai? Essentially, the developer has to get consent of 70% of eligible slum dwellers. So who's eligible. It's slum dwellers who can show that they were living in a slum prior to January 1st, 1995. And so a developer has to go to a slum, say, okay, we want to redevelop this slum, and we need to get 70% of you to sign your names and say that you consent. What happens, why would you consent? Eligible occupants are compensated in kind with a 25 square meter, public housing unit. That is, supposed to be, even in the law, it says in situ as much as possible. So, what the urban planners are imagining here is that, best case scenarios, you have slums built at a low density, low height, even though it's very high population density, and you allow a redeveloper to come in, build, 10, 20, 30-story building, and then in concession for that, they build these public housing units next door. So what we have seen is through kind of many reports, both through news articles and us talking to NGOs and real estate developers within Mumbai, is that two things. First, this enforcement of as much as possible is not 100%. So a lot of the time you get people that are compensated, but not in the same location. We have data on the location of these new public housing units, and most of them are out towards the outskirts of the city. And then second is the fact that there's frequent reports of signatures being forged or this being waived. So we should think of this as many policies in India as not being perfectly enforced. But overall, what I want you to think of, and how when we get to the structural model, how we're going to think about it, is that you have some probability of being compensated, which will be a probability of being eligible, and that we can observe because we have some data on how long people have lived in slums. And then there's going to be some probability that you actually get rehoused in situ, and that we would have to make some more assumptions about, but we do have data on the location of these houses, so we could either just do, run different exercises over that, or we could calibrate that to the share of these new developments that are in the city center versus in the outskirts. So yeah, great questions, thank you. Okay, so I'm sure there's plenty more to talk about all the institutional details, but let me crack on and talk to you about data. Make sure I don't get sun in the screen. Okay, so I'll go over fairly quickly over this, but I'm happy to talk more probably afterwards about these data sets. So first, we gather data on formal sector floor space prices by digitizing these books of government assessed values across around 600 subzones in the city. We get data on employment from 3 waves of the economic census. This gives us data on the universe of formal and informal establishments. And we digitized a large number of hand-drawn maps to actually locate these across approximately 900 geographic units within the city. Population data we have from the population census across around 230 election wards. We have data on educational composition by neighborhood, as I'll describe in a second, using 2 sources of raw data. First, we have the socioeconomic and caste census from 2011 that gives us lists of everybody living in Mumbai, including their name and their education for 1 year. And then we have these lists of voter rolls from 2002 and 2017 that gives us the names of every individual registered to vote in the city of Mumbai by the election ward that they're registered to vote. We have data on building heights using aerial radars. This data is called LiDAR data from one wave in 2011 that we'll use in the quantitative model. And then we have data on slums that come from 1 year's worth of what are called ground truth data, which comes from the Slum Rehabilitation Authority of Mumbai, which has a map that they generated using satellite kind of scoping and then census work using a kind of building-based definition to say where slums are located, where they define slums by low quality buildings rather than tenure or something that wouldn't be observable. And then we're also going to use high resolution daytime satellite imagery between 2001 and 2016 to try to measure how slums change over time, as I'll show you now. Okay, so as I mentioned, unfortunately, we want to look at changes in slums over time, but we only have 1 year's worth of data on the location of slums from administrative source, which is this Slum Rehabilitation Authority map in 2016. However, we do have satellite imagery, daytime satellite imagery available from 2001 onwards. And so what we're going to do in this project is use frontier machine vision techniques, a deep convolutional neural network, to measure slums from daytime satellite imagery. And this is essentially going to allow us to solve our missing data problem. So because we have satellite imagery, pre and post policy, we can then apply this neural network or just some function to that data, and it's going to predict the map of slums. And so we can use that to measure how they're changing over time. Slight caveat to this, because this is still in process. So some of the results that I'm going to show you today use a kind of intermediate step that is not the final step that we want to do. So let me just tell you now what I mean by this. So what is our overall approach going to be here? You know, as you can see, we're going to train a neural network on the 1 year's worth where we have ground truth data, which is 2016. We're going to train it on the suburban part of the city, which is outside our kind of area of interest in the north. And then we're going to use that trained network to predict the location of slums for Mumbai city, as I mentioned to Nina, for all years. So how can we do this? Well, in 2016, it's pretty simple. We almost don't even need to do that, right? So we can use the 2016 slum map to train the network on suburban and then predict for Mumbai city. Now in 2001, where we want to go is to use that network trained on the 2016 ground truth data to predict slums for all of those other years, all the intermediate years, which I think is kind of clear. That's the reason why we want to use this in this project to fill the missing data problem. But there's a lot of difficulties doing that. There's differences in the satellites across over time, which means that it's very hard to predict these kind of out of sample years. So what we've done is expanded our library to include a lot of techniques such as data augmentation and regularization to try to do this properly. And we're almost we've been prototyping it. We're almost ready to include it in the results. But what I'm showing you today is kind of old results we have from a year or so back, where we get our RAs to update the ground truth slum map for 2001. So what do I mean by this? They're going to go to 2016. They're going to see the slum map, the ground truth data from the SRA, and they're going to see the satellite imagery. So they're going to learn, okay, this is what slums look like in 2016, according to the SRA. And they're then going to compare the satellite imagery from 2016 with 2001. And so in areas where slums haven't changed, then they can say, okay, that's what a slum looks like in 2001. And then they expand that definition out. So they get a new ground truth slum map for 2001. You know, in essence, we could do all of the regressions using those 2 years worth of manual data, and we've done it, and we get the same results. I think there's 2 reasons why we would even want to use these methods in the first place. The first is just, you know, it's less arbitrary than having RAs or PIs decide where the slums are. When we had 2 RAs, digitize them, and then or make slum maps, and then kind of concorded them, and we saw there were a fair amount of discrepancies between them. I actually had to go in and kind of clean them up. The second reason is that we have satellite imagery for almost 20 years now, from 2001 onwards, and there it's clearly not kind of scalable to do it year by year, having RAs who disagree do every one. So we want to kind of fill in, use the network to do the analysis for this all the intermediary years, and then we can do event studies and look at the dynamics of slums over time. So with those caveats, let me show you what our prototypes kind of look like. So this is ground truth data, the Slum Rehabilitation Authority map of Dharavi, which is the largest slum in Mumbai, just south of the airport. This is out of sample, so we haven't used this in training the network, but then we can compare this kind of validation out of sample data with our predicted slums for Dharavi using this deep learning approach. And so what I think, you know, what I take from this is that the network does pretty remarkably well. Here, the blues are the borders of slums and the reds are the interiors. And so I think it does very well in managing to disentangle formal, modern buildings within large slums, like in Dharavi. So here you can see this kind of agrees with the SRA's map. And the second thing that's quite cool is that it manages to pick up these small slums outside. So this is just a picture. I've obviously cherry-picked part of the city that looks pretty good. You can also do this across the whole city as well. Again, all out of sample Mumbai city, not suburban. And here we're plotting area of slum maps according to the ground truth data validation with that predicted by a neural network. And so we see it does really well with R squared of 0.94. To understand whether or not this is doing well, we compared the fit of R method with the former frontier method that extracts a number of spatial features from the imagery using a library called SPFees, and then runs a random forest classifier on those features to try and predict whether or not locations, groups of pixels are slums. And so when we do this, we find an R squared of around half as much, so 0.45. So we think this is kind of proceeding pretty far in terms of being able to measure slums more precisely. The second piece of measurement that we're going to do, which I'll kind of skip over fairly quickly, is we're going to have to, we lack data on the educational composition of neighborhoods, right? So if this was like a study in the US and we wanted to see how gentrification was changing, I would just get 2 waves of the census. I'd measure the share of college educated people in neighborhoods and I'd be done. But in India, we don't have this data. But as I mentioned in the intro, we're going to exploit this idea that in India, names are informative about castes and castes are informative about education. And effectively, what we're going to do is just measure a reduced form. So we're going to try and predict people's educations from their names. So this is going to be done in 2 steps. So first, we're going to estimate this mapping going from names mapping to education. So here we're going to use that this socioeconomic and caste census in 2011 provides lists of 2 variables, every Mumbai resident's name, and then their education level coded from 1 to 6. And so we're just going to estimate this, this function f that maps last names into education by first encoding names into a numeric format and then running an extremely randomized tree classifier to estimate that function. Then once we have that function, we can feed in the names from the voter lists that we have according to where people are registered to vote in 2002 and 2017. And that then gives us our predicted education for each individual by election ward where they're registered to vote in each year. So, you know, we don't, while the census doesn't have data, this disaggregated spatial units on education, it does have data at larger units across, I think it's around 27 wards or 23 wards across the city of Mumbai as a whole. So there, what we can do for validation, again, we haven't used that data to train the algorithm, but we can look at how the average literacy rate of these wards, according to the census, matches up with our average education index predicted only using the names of individuals. And so we can see this kind of correlates pretty well. So it gives us faith that, you know, that we're predicting education well, and we're matching the spatial distribution of education according to the data that we can get on it. Okay, so I can stop there and take any questions.
Hi there, Nick. So I think a bunch of these questions are still from the previous section, but they may still relate here too. So there's one from Peter Morrow. So Peter, if you want to ask the question yourself.
I think it was answered when Nina's question was answered.
Perfect. Okay.
I can wait until the model section if there's more.
Yeah, perfect. Thank you.
Great. Let's maybe to get to the model section, Fabian, I'll power through the reduced form just to have 10 minutes at the end for the model.
Okay. So we postpone all other questions till later on then.
Yeah, I'll stop at the end of the reduced form for 1 or 2. That sounds good.
Perfect. Yeah, thanks.
Okay. Okay, so first we want to think about, we have these locations where these mills are being redeveloped, skyscrapers are going up. How do we want to measure treatment effects from that? We're going to use 2 measures, fairly simple. So the first measure is going to be the distance from a polygon boundary to the closest mill boundary. So this distance to mill boundary is going to be 0 if a polygon contains a mill, and it's going to be greater than 0 if a polygon doesn't contain a mill. Okay, so why this, you know, this would be obvious if if our geographic units perfectly overlaid the boundaries of mills, but unfortunately they don't. So just to show you some examples here. So here we have geographic units outlined in blue, and the mills are in red. So here, this geographic unit A contains a mill inside it. So that's going to have distance to boundary 0. It's going to contain a mill. This geographic unit here, B, is going to be a short distance away from a mill. So it's going to have a positive distance, but small. And then this geographic unit C is going to be further away. Okay, so pretty simple. The second measure that we're going to use kind of goes towards Gabe's question at the end. So this is there. I'm not sure if there's a good example in this picture, but we have a 2-dimensional spread of these mills across space. So it may be that one mill, 2 mills are 100 meters away from the closest mill, but one has mills on 3 sides and the other has mills only on 1 side. So we may want to account for the first mill as having a greater intensity of treatment. And so to use this, we're just going to construct a multilateral mill exposure measure. So that's just going to be a sort of distance weighted average of the mill density in places close by. And so this is going to be very similar to kind of multilateral market access measures that we use in trade and economic geography. Okay, now of course, the first thing to say is kind of anecdotally we think, and I want you to believe that this policy was unexpected and uncorrelated with fundamentals. But the worry is that this could have been anticipated, or even more problematically, it could have been a result of the policy change. Could have been the result of lobbying of mill owners who were trying to benefit from growing land values and gentrification that was already happening in neighborhoods close by. In which case, everything we would be picking up would be kind of due to reverse causality. So what we're going to do here is we're going to exploit the only data set for now where we have annual data over a large span, pre and post the policy, which is going to be on formal sector house prices. And I think this is actually the exact data set that you would want to have if you do want to analyze pre-trends, because as opposed to other measures of real economic activity like residential choices or employment, we expect house prices to adjust pretty instantaneously to news or different beliefs about how things are changing. So if this policy was anticipated, if it was the result of underlying trends and growth in these areas close by, formal sector house prices would be the place where you would see that first. And so what we're going to do is we're going to run a regression looking at, we're going to run a regression of formal sector house prices in each year on a dummy for whether that location contains a mill. And we're going to just allow that coefficient to vary across years. So we're going to identifying variation in this regression is going to come from comparing house price growth within spatial units relative to a base year across subzones, which are geographic units, within one of 4 regions R, which are larger kind of geographic areas in the city, controlling non-parametrically for region year trends through these fixed effects, and also allowing for trends according to initial characteristics, X, which could be things like distance to CBD, area, demographic characteristics. Okay, so here we see the plot of these coefficients, and so I think the main takeaway is that we, to my eye, we don't see that significant pre-trends here. So here, what we can see is relative to the base year, there's kind of no impact of containing a mill leading up to the policy announcement in 2001. So it doesn't look like there's much of an anticipation effect. After 2001, when it was announced, we do see some slight pickup, but it's only after the Supreme Court decision in 2006 to confirm that initial decision in 2001 that we really see house prices grow, by 20% relative to other places that don't contain a mill within the same region. So I think this is nice, not only showing that there's no large pre-trends, but it's kind of really consistent with this story of there was first this announcement and some uncertainty, but after that uncertainty was resolved, these activity really started to change nearby. So then our main regression is just going to be looking for all of our different outcomes, at how they grew pre and post the policy, typically looking between 2000 or 1998, 2013, 2015, or 16, depending on the data sets. And I'd be happy to clarify a little more about exactly what the pre and post years are. And so what we're going to do is we're going to look at changes within geographic units, comparing places that contain a mill, places that are 1 meter to 500 meters away from their closest mill, and places that are 500 meters to 1 kilometer from a mill. Okay, so like while this contains mill, this first dummy can actually contain a bit of a spillover, right? Because if we go back here, you know, region A does contain a mill, but it also has plenty of places that don't contain a mill. We can't distinguish between those. The second two coefficients are going to be pure spillover effects. So these are places that don't contain a spillover, but are you know, within 500 meters of a mill. So what we see, just to summarize the effects pretty quickly, is that formal sector house prices rise, and that effect decays through space. So we see around a 13% rise in house prices in places that contain a mill, around a 9.5% rise in places less than 500 meters from a mill. Where formal sector house prices are rising, we see the share of slums falling, which is kind of consistent with the relative return to formal sector development rising. Kind of makes sense that informal sector development would fall. Formal sector quantities would respond to the change in formal sector prices. We see that informal employment density also falls, which is consistent with some descriptors that we show in the paper, that informal employment density. Here we define informality by size. So this is in establishments less than, I think it's 5 employees, it could be 10. Because we have that data over time. We also have some data on whether firms are registered in 1 year, and we see that size, you know, correlates very highly with firm registration. So this is consistent with the fact that a lot of informal employment happens within slums in our data. But when we look at formal employment, we don't really see any big effects. So, you know, this story of these mill redevelopments unleashing huge density of formal employment activity, it just doesn't really seem to be jumping out of our data. And I'll talk a little more about different ways we can cut it on the next slide. We see that the average education of residents rises, at least within the locations that contain a mill. These geographic locations are much larger. There's only 230 of them. So here, you know, there may be a spillover in that own effect. It's just hard for us to tell. And then we also see population density falling. Okay, and so we think that this is consistent with richer people moving in, each of whom consume more housing floor space per capita, and slums being demolished where poor people lived in very dense small areas. So this is also telling us that this story about high skyscrapers promoting very dense living in cities is not necessarily you know, one-to-one, because different sorts of people live in very tall buildings, and so density actually falls in our example.
And Nick, there's a clarifying question here by Tommaso Porzio. He says it seems that 0.783 is a large effect in the opposite direction. Can you comment on that?
Yeah, no, we're trying to look into that to try and understand what it is. I mean, it's kind of imprecisely estimated, but yeah, good point. We're trying to understand that. We have a lot more results on formal employment. I can try to show you in a second.
There's another quick clarifying question. Why are the sample sizes decreasing between the specifications? And what are the differences between the subsamples?
Yeah, so the differences in the sample sizes just to do with the different geographies that these data are coming at. Like for instance, these education index and population are across these 227 election wards, some of which may not have data in some years, especially for education index, because we're predicting it using these voter lists. Residential prices are much, we have more spatial units, so that's why the sample sizes are changing. It's just due to the different geographies.
I see, okay.
Okay, so we then wanted to dig a little more into the employment effects. So could it be that, you know, these average treatment effects are just masking a kind of heterogeneity that's going on underneath? We see around the majority, I don't remember off the top of my head, but the majority of these mills are redeveloped for residential purposes. I think it's around 60%. So could it be that these formal agglomeration spillovers are actually taking place, but it's only near commercial mills? So it's only, you know, our theories of agglomeration would say it's only when you drop a bunch of employment in one location that we would think productivity and employment in nearby places would increase. We find, you know, no real evidence of this. So when we dig into it and we do heterogeneity analysis by mill use, we see that formal employment does increase substantially in locations that contain commercially redeveloped mills, that's almost kind of a first kind of a sniff test just to say whether our different data sets are speaking to each other, right? So where we code a mill as being commercially used in the economic census data, we see, I think it's more than doubling of formal sector employment, but we don't see any spillovers into surrounding locations. Informal employment tends to fall less by near commercial mills, which could say something about kind of linkages. It could be that there's more foot traffic near these commercial mills that allows certain types of informal firms to survive and be willing to pay the higher land values. But we don't find that difference is really too significant, so we don't stress it too much. Now, it could be that formal agglomeration spillovers are taking place, but just in certain industries, like high skilled services, for example. But we don't find any evidence of this. We find that formal employment is unchanged near commercial and residential mills for all industries. We also don't find evidence of retail, formal employment in retail sector increasing near residential mills, that we would think of as a lot more shopping and these sorts of things. So, you know, our broad takeaway from this is that there doesn't really seem to be evidence of huge formal agglomeration spillovers, at least in our time horizon. I think that's the big caveat here. So, you know, our employment regressions are going from 1998 to 2013. We're looking at mills that were for the commercial redevelopment, I think it's before 2011. So most of them are redeveloping between 2006 and 2011. It could just be that there's not enough time for these effects to show up. I'll end the reduced form just talking about what else we can do to kind of provide more evidence of these causal impacts. So one thing we do is an industrial land placebo test, right? So one thing we might worry about is that, you know, these mills were just large industrial areas, large industrial buildings, and there may have just been a process of gentrification going on over the time, whereby the demand for these sorts of buildings and the technology to redevelop them is just increasing in aggregate. But we actually digitize the location of industrial land and plots that are large, around the same size as our mill sites. And we find that there's no impact of proximity to that industrial land once you control for distance to the mill. So it really does seem to be something about your distance to these textile mills for which this policy had a change. We also look at employment pre-trends. So we find no impact. We have 3 years worth of employment data, and we find no impact of exposure to mills on employment between 1998 and 2005. Remember, 2006 is the year that this policy is really starting to have bite. So all of these employment effects, in particular these decreases in informal employment, they're all happening between 2005 and 2013. And then lastly, it could be that, you know, even if this policy was unanticipated and exogenous, it could have crowded in coordinated investments in public goods from the government. They're like, okay, there's all of this private sector development going on now. Let's provide some public goods in order to support that growth. Here we digitize the one data set that we have on a measure of public goods over time, which is roads, and we find no significant evidence of changes in roads over the period. We have some additional results. Let me get in. I think we have about 8 minutes left, so I'll get into the quantitative model. Unfortunately, I don't have results to show you today, which will make going through it a little easier, so I can just kind of go over the main ingredients. But I can either stop here, Fabian.
Yeah, right. I think that would be a good idea to take at least 1 or 2 questions, and then you can run with your talk until 12:15, given that you have taken questions throughout.
No, that's good. Maybe 5 minutes extra, but I think we'll be fine. Be good to have some discussion at the end.
Perfect. So maybe Kirill has a question that has been upvoted a lot. So Kirill, if you want to ask your question yourself.
Yeah, sure. Thanks. Yeah, it's a very basic question. So you showed us the pre-trends very nicely for, where treatment is just having the mill on your in your place, but what about doing the pre-trend regression for house prices for all of the treatments you have, like being within 500 meters, within a kilometer, and so on? Have you done that?
We've done that. The ones that I have on my computer do just the different measures of exposure within a location. I think we've also done that. I also have the multilateral measure excluding the location itself. So that's just your exposure to mills close by, but not whether you have any within. And I think I did the ones that you have that you were suggesting earlier on. So yeah, we see the patterns, broadly similar, however way we cut it.
Perfect. Do you want to take another question now, or we can? There's not. Yeah.
Please. Yeah.
So there's a question by John Heilbronn. John, if you want to ask your question.
Hi. Yeah, I was just wondering, you seem to use CAST as a way of getting to education, which, seems like a valuable inference exercise, but given the context, CAST itself might be independently interesting. So I was just wondering if you thought, first of all, I was just wondering, institution-wise, how does CAST map to education? And have you thought at all about using CAST, seeing what you can learn about, sort of sociological relationships by using CAST as its own variable?
Yeah, no, I think that's a super interesting. So to respond to the second part of that question, yeah, unfortunately, we haven't got to that. And I think looking more into that would be very interesting. To answer the first part, we're doing more reduced forms. So, the mapping we have in mind is name is informative about caste is informative about education. So we could do that, and then that would allow, so if we measured those two functions, right, which would be predict caste from name, and then just look at average education by caste, then we could that would unlock all of the exercises you were talking about as well, because we would actually measure caste. What we're actually doing is just a reduced form. So we're just going from name to education directly, with the intuition that it should work because names are informative about caste and that's informative about education.
Great, Nick. Should maybe move on now, since the other questions are not really, strictly related to the previous section.
Perfect. So I'll just go for like eight, just a couple minutes over, but yeah, I think that should be fine. Okay, so the key empirical features that we kind of document are first these land market spillovers, that we have these large formal sector house price increases within and near mills. But we also see this reallocation and sort of gentrification effects, right? So we see slums converting, average education of residents rising, and informal employment falling in locations in and nearby mills, with no real big impacts on formal employment. So this kind of motivates us to think about a couple of questions. So first, how much of these reduced form effects depend on the fundamental spillover, this direct effect from building quality into kind of amenities or house prices, and how much is due to the reallocation of all this activity across space? And in answering that, like how much is due to the particular geography of Mumbai, right? So can we take these estimates and port them to another setting? Or can we estimate the fundamentals in a model that would allow us then to fit different data from a different city, and that would then give different predictions about the impacts of counterfactual policies? And then the second question is kind of what I motivated the talk with at the beginning, which is just how can we think about parsing this multitude of effects to think about the aggregate and distributional effects of this class of urban renewal policies within developing country cities where slums are present. Okay, so to answer these questions, we're going to set up a model that's going to have two components to it. First, there's going to be a static equilibrium that's going to play out period by period, where amenities will depend on the quality of housing nearby. There's going to be multiple skill types of workers with non-homothetic preferences for amenities. So richer workers are going to be more willing to pay to live in high quality neighborhoods and high quality formal housing. And then there's going to be informal land and labor markets. There's then going to be a dynamic equilibrium that links choices over time, whereby residents make these dynamic choices about where to live subject to Calvo frictions. And so adding in this dynamic component is going to be really important if we want to think about distributional effects. Without any dynamic frictions, everyone would just be the same as well off every period because everyone can just freely adjust to make a new choice. Here, where you are today is going to impact your expected utility tomorrow, because with some probability you'll have to stay in the same place. And so now that's going to affect the incidence of this class of policies, because for some people who reside in slums, which are now redeveloped, they're going to actually have to bear the increased cost of paying there in response to these, of living there in response to these policies. Now, these are going to be kind of the core ingredients to think about measuring these spillovers. When we want to talk more seriously about welfare, we're going to have to add in some additional structure, kind of to map to what Nina's question was getting at, which is to kind of speak to the institutional context at hand. And the way that we're going to do that, I'm not going to show you this today, I'm just going to tell you how we're going to do it, is that for those who are relocated from the slums, we're first going to know the location of these public housing buildings. And we also know from the data the fraction of slum dwellers who are eligible for compensation. So we're going to know that conditional on being redeveloped and offered, we're going to know conditional on being in a redeveloped slum, how likely you are to be compensated and where is that compensated housing likely to be. And then we want to estimate the value of that compensation, that housing. And we're going to do that by introducing an amenity for that public housing. And we're going to estimate that amenity to match some experimental evidence from Bernhardt, Field, and Pandey, who look at a housing lottery in Ahmedabad, pretty close to Mumbai, that looks at a similar sort of policy and estimates the long run share of compliers who end up, 20 or 30 years later, decide still living in those buildings. And it also measures the share on impact who accept the offer. So clearly there's going to be kind of a one-to-one relationship between the amenity of the public housing in our model and the share of people offered it who actually accept. That's not going to be in today. Okay, so Fabian, I'll take till 6:05 if that's okay, and I'm just gonna go for I'll explain the setup and then I'll just go quickly over estimation. Oh, actually, I'll just skip that estimation. Okay, so there's going to be different locations indexed by I and J, which are discrete, and two types of housing, informal and formal. A worker of individual omega of type G, which can be low or high skilled, enters the period living in location I in housing type K. And they will then make a static decision in each period to choose the location J to commute to. And they're going to receive this flow indirect utility, which is just this common component of utility given by V, I, J, K, G, which depends on the amenities from living where they live in the type of housing K, as well as on this kind of consumption bundle, where the indirect utility is going to be their income accounting for the price of housing, that residential housing where they live. And then that common component of utility is going to be decreased by their cost of commuting. So a standard kind of iceberg cost if they choose to go from I to J. And these preferences are going to be non-homothetic. So this row less than 1 is going to imply that amenities and consumption are complements. So the rich are going to be more willing to pay to live in high amenity locations, be that high amenity neighborhoods or high amenity type of housing. Okay, and so the row going to 0, sorry, that should be 0, not 1, is going to be the standard case of Cobb-Douglas, which this nests. So then for commuting, workers are going to commute according to our standard kind of gravity type structures. For the firm, there's going to be in each location, there's going to be two types of firms, informal and formal, which can produce in a location and a type of housing K. And they produce using an Armington technology over, which is Cobb-Douglas over commercial floor space and labor, where the labor input is a CES aggregator over low and high skill. Okay, and so these weights mu SG is going to be the weight that firms in sector S put on labor type G. And this is going to allow for informal and formal firms to differ in their relative demand for low and high skill labor. And this is going to be important both to calibrate some unobservables of the model as well as to think about welfare, because when certain types of firms move out of places, that's going to hurt most the types of workers for which they demand the most. Housing supply is kind of the main new element of the model. So there's going to be two types of development: formal development, where developers combine land and capital to produce multi-story buildings according to a standard kind of Cobb-Douglas production function. They're also going to face a tax on their revenues if they choose the formal option. And that gives us a profit per unit of land developed, which is increasing in the price of formal floor space. They also can choose between this informal technology, which just constructs single-story buildings, which are not subject to development costs. So the profit if you build informal buildings is just the price per unit of land in the informal sector. The developer problem is then going to be that within each location, there's going to be a total supply of land, TI, and we're going to assume that there's a continuum of plots. So here we're abstracting away from kind of large developers who may internalize things across different plots. That's a definite kind of weakness of what we're doing here. And so the problem is just going to be to choose for each plot the land use type that maximizes their profits. Okay, in standard assumptions, we're going to assume that idiosyncratic term is extreme value. And that's going to give us these very nice closed forms expressions for the share of land that's allocated to different uses within locations. So the share of land allocated to formal use is just going to be increasing in its relative price. And then once we have these land shares, we can compute total floor space supply in a location, which will just be equal to the share of total land allocated to each technology, the total amount of land there, and then the density of development on each unit of land. The residential choice problem, I'll just skip over pretty quickly, but just to give you intuition, there's going to be dynamics here because with some probability, individuals are going to be able to move between periods. So as another way to say that, with some probability, they'll be stuck in the same location and they won't be able to freely re-optimize. And so then, solving that problem and making standard kind of Rust style dynamic discrete choice assumptions, we can kind of get clean expressions for the lifetime utility of being in different locations, and then the choice probabilities, both conditional on having the option to move and then unconditional, just the average probability that you move between different locations. There's going to be amenity spillovers where I'm just going to wrap up. I'm going to take one more minute now to wrap up. And I'll actually just end with the intuition of the model. So there's going to be amenity spillovers where amenities in a location depend on the quality of housing nearby. So it depends on the density, the amount of formal floor space nearby with elasticity mu f, and then the amount of informal development close by with elasticity mu I. And then we're also going to allow for an exogenous component of amenities from living in each location I and housing type K. Okay, so that's going to incorporate, importantly, it's going to allow for formal housing to just be higher quality in general than informal housing. And then we can kind of characterize the equilibrium from this. Just to give you the intuition for what's going to happen in the model. So, right, suppose that we have these locations that are outside the model in the first period. You can think of like an infinite tax on development there, where you lift that tax only for formal development. So you have a shock in the supply of formal floor space there. What that is going to lead to under this model is an increase in amenities in locations close by. Land values are going to rise. It's going to be more attractive to live there. Rich, high-skilled individuals are going to be more willing to pay for that increase in amenities, particularly so in formal housing, if formal housing has higher amenities and levels, because they're more willing to pay for high amenities. And that's going to mean that the relative price of formal floor space in those locations increases. We saw that in the model, these relative land prices are going to in turn determine the relative land use with some elasticity that's going to mimic kind of conversion costs of converting slums to formal land. And that is going to then mean that the slum share falls. And then informal employment and incumbent low skill workers are going to move out, but some are going to be stuck there. And so the incidence of this kind of fall in utility in those locations is going to fall on their backs. We kind of estimate the model. The intuition for estimating the model is matching, is writing the model in kind of DEK format, feeding in the shock, which is going to be the change in house prices, generating the pre and post data, running the same regressions, and then matching, searching over the deep model parameters to match those reduced form coefficients. But I've already way overtaken my time, so let me just conclude there by saying that the main things we do in this paper is exploit a unique policy change to show the spillovers from urban renewal in a developing country megacity. We incorporate new data using machine learning to measure slums and gentrification, And then we combine this into a quantitative dynamic urban model with informality to allow us to interpret the results. And I think the main takeaway is that we find large spillovers from urban renewal into the structure of the surrounding neighborhoods that drive a process of some conversion and gentrification. Thank you.
Great, thank you very much, Nick. I also lifted your co-author, Mike Gechter, onto the panel. So Mike, you can also help answering if you want to. The first question is by Macy Wong, which was posted a while ago, but Macy, if you want to still ask it, please go ahead.
Oh, I just wanted to know, thanks for the presentation, Nick. I just wanted to know can you say a little bit more about the policy? What did it do? And at the same time, was there also changes in zoning regulations?
Yeah, so the policy literally, so just beforehand, pre-1991, you literally couldn't redevelop these mill sites at all. 1991 to 2001, you could redevelop if you gave 2/3 of the land to the government. And then what the policy in 2001 precisely did is it basically changed the wording of that previous policy to apply to only vacant land on the mills. And of course, the majority of the land on the mill sites had some construction on it. So de facto, it kind of just lifted these restrictions. Second question about zoning. Yeah, so like we had that evidence on roads because that was the only thing we could measure over time. In terms of the zoning in Mumbai, it's done. Mike can maybe help me out, but actually there's no need. We can take other questions instead, but I think it's every 25 years they do a development plan. So I think the one over our period was the development plan of 1991, and that defines the zoning. And then that stays constant until 2016. There were some changes in floor area ratios, maybe, but I'm not 100% of that was going on at the same time, but those were in Mumbai suburban, they weren't in Mumbai city.
Great, thank you very much, Nick. There's another question by Don Davis. Don, if you. Yeah.
Hello, can you hear me?
Yeah, perfect.
Okay, thanks a lot, Nick. Very interesting work. The questions that I had are really about sort of the policies being imposed, which have some restrictions imperfectly enforced both on the number of people who have to assent to these changes, and also, again, imperfectly enforced restriction on in situ development. And I guess that the question is, once you have something that says that you need assent, why do you want to additionally have the in situ requirement? And I guess at least one potential response would be, well, you know, and especially responding to your later thing, maybe some people are really, really attached to the location and have really high costs of moving. But that would seem to argue instead for making the rights to take advantage of these things transferable, so that they could effectively sell off the right to move. Because it doesn't seem obvious that you want to find some way to keep these people in exactly the location that has, you know, valuable alternative uses.
Yeah, no, I think this is a great question. Like, as to why they, I mean, so I think what you're suggesting, it probably makes sense to me that's if you just assign property rights, right, that people should go to an efficient outcome, and that the residents can choose whether they stay or whether they sell and then move out off to the outskirts. Yeah, I mean, I don't think we have the data to talk to that. Something that we can maybe think about in the counterfactuals, although I'd be very skeptical that we have good data to discipline the kind of micro parameters of that. As to why they implement it, I mean, I guess it's in a world with imperfect enforcement, right? Like if you say, okay, in principle, you should give them at least the right to live in, you know, have a unit in situ, but you have then developers forging signatures and bribing officials, then it can be a way to try and enforce that. Because the core intuition, I think, is that, you know, in cities where there's poor public transport, location provides you access to jobs, and that's what slums and central areas provides, even if it is kind of inefficient and maybe good for equity. So you don't want these processes just to drive out all of the low skilled by default. You want them to, in your perfect world, yeah, have the option to choose, but in an imperfect world, yeah, just grant them the rights or give them the unit of housing in that location.
To just quickly add, this is kind of a general tension in slum redevelopment, which is the really a political economy issue, which is to say that there's discomfort with providing very high value compensation, you know, from the perspective of other voters, because the point of view is that, you know, these folks broke the law by coming and settling on this land that wasn't theirs. And so that places constraints on what kinds of compensation you can offer.
Oh, Fabian.
I think Fabian, can you hear me, Nick?
I can hear you, yeah. Okay.
Okay, I think Fabian might be having connection problems. So I think we've got time for maybe one very quick additional question. So Tomaso, you should be able to talk. We've got 1 minute, so if you might be able to make it quite brief, that'd be great.
Yes, sure. Hi, Nick. Thanks for a great talk. I just want to kind of like, you to comment a little bit on how you're thinking about the timing. So if I understand correctly, you're going to estimate the model looking at the new steady state. But so are you thinking about the data being like already like in the long, are you capturing the long run impact is like, 15 years enough? Just pretty much want to just hear your mind about like, the timing of model and data, short run versus long run.
Yeah, no, I think so. We haven't got into calibrating the model, but in short, we have 2 periods of data in the data. So yeah, we're probably thinking about that as 2 long run equilibria, and then it's going to be, yeah, I mean, we're going to have to think about how to calibrate the periods, I think. But the exercise will basically be, yeah, feed in the shock, and then however we calibrate the time periods, I guess let it run out for however many periods we have, which is around about 15. And then it will only really, in terms of the model, it will just affect the residential, the estimation of that side of it, because the rest of the model is very simple and it's just a static equilibrium. So I can think a little more formally about that, but I think we're out of time. Fantastic.
Well, there are lots more terrific questions. For those of you who we didn't get to, apologies, but Nick will receive a transcript. And I'm sure we'll welcome all the questions that we didn't have time for you to ask in person. But thank you all very much for joining and for this great degree of participation. And thank you very much in particular to Nick for a fascinating presentation. We hope to see you all next week.
Thanks, everyone. Bye.